Guys, hopefully you guys finished up these 1 through 7 here, skipping 3. Let me just check with my key here. So number 1, right, if you got them, great. If you got them all wrong, you have no idea what you're doing, then, ask questions. We're going to do 2 days of 1.7, so hopefully by the second day you'll get it straightened out. But number 1 should be f inverse of x equals x plus 1 over 4. Number 2 should be f inverse of x, or h, it's actually h inverse of x. Will actually equal 1 over x, which is interesting. That just means the original is the same thing as the inverse, which means when you reflect it over y equals x, it just reflects on top of itself. Number 3, I said to skip, so don't worry about that one. If you did do it, it would be x plus 2 and negative x minus 2, but it would only be for a domain of negative 2 to infinity. It's like a domain restriction on there, which two of these other ones will also be. Number 4, f inverse of x, or actually, sorry, I keep screwing up these letters. It would be j inverse of x equals x to the third. Number 5, if you did it, what you notice is this is the square root of 4 minus x squared. Now, when you actually go ahead and do the inverse, you will get, f inverse of x equals plus and minus the square root of 4 minus x squared. So it kind of looks like the original. It's actually different. The plus and minus is key here, so you got to make sure you do positive and negative when you take a square root. But the domain of this, you have to restrict the domain. It's not the full square root of x squared, plus and minus the square root of 4 minus x squared. It's only from 0 to infinity. And that's because if you look at the original, the range of the original is only going to be 0 to infinity, right? That's just what the range is going to be from something that would result from this. So you just got to make sure that the range of the original matches the domain of the inverse, which for these ones over here, it didn't matter, right? It already worked out to be the same thing here. But when you did this, plus and minus the square root, right, the domain of that one is not just 0 to infinity. It's, negative infinity to negative 2, union 2 to infinity. Or actually, I'm sorry, it's only between negative 2 and 2, but it's always a good check to make sure. It's actually only going to be 0 to 2, which is trickier. But if you said 0 to infinity, that's fine. Just make sure that the range of the original matches the domain of the final. And it usually does take care of itself, but in this case, because it's a weird shape, it didn't. Number 6, if you did number 6, it's f inverse of x equals 3x plus 6, which is another line. Keep in mind all of these shapes match. And then number 7, it's interesting, right? So it's another one of these ones with the domain and ranges, because the original is a square root, right? So the range of that one is 0 to infinity. Now when you did the inverse, you should have gotten w inverse of x would equal x squared plus 3, which is great, but this is a full parabola, right? The original is only half of a sideways parabola. That's just the shape of a square root. So again, you just need to make sure that you restrict the domain of this parabola to only 0 to infinity so it matches the range of the original. Because you don't want the full parabola, right? You actually just want a half. So like if this was a full parabola, well, this is the square root, right? So these two things are not reflections of each other. However, if you erased, negative infinity to 0, now all of a sudden these are reflections of each other, and that's exactly what you want. So a little tricky, a couple curveballs in there. All right, so here we go. This is just kind of a review of inverses a little bit. So, if you have a function f of 4 equals negative 1, all that means is you plug in 4 and you get negative 1, right? So you plug in 4, you get negative 1. It's a coordinate point. So we should be able to find all of this and make sense of all of this, right? So this means f inverse of negative 1, right? What does that exactly say? It means if I plug in negative 1 into the inverse, what should I get? Right? Well, let's think about it. If the original has 4 comma negative 1, that means the inverse has the coordinate point of negative 1 comma 4. So if I did f inverse of negative 1, that would be like, what is the result if I plug in negative 1? Well, the result would be 4. Right? If I plug in negative 1, I get 4. So, making it a little bit more complicated, if I said f of f inverse of negative 1. Well, I know that f inverse of negative 1 is 4. Right? The same problem I just did. So basically it's just saying f of 4. So what's the original function value, because not an inverse anymore. What's the function value when I plug in 4? Well, it's equal to negative 1. It's almost like the f and the f inverse, they undo each other, and the resulting value is just going to be negative 1. So same thing here, you're going to see that the f inverse and f will undo each other, and it'll just be equal to 4, right? So f of 4, same thing as here, that's going to be negative 1. So it's basically f inverse of negative 1, which we've already done that problem up here. That was equal to 4. It's just basically jumping back and forth between these two coordinate points. Those would be the only two numbers that would ever pop up as answers. All right, so last thing that I want to do today is just getting you guys to prove these, which there's two different ways. If you're going to prove it with composite, that's great, right? The definition of an inverse was that, it said f of g of x are inverses if f and g of x are inverses if f of g of x equals x. So if you take the inverse and you throw it into the original, and then vice versa, if you take the original and throw it into the inverse, and it all simplifies to just be x, then those two things are inverses of each other, right? And you have to do it both ways, but if it works one way, it is going to work both ways, but you just have to do it to prove it. So if I did this one down here, right, prove that these two things are inverses. So here's the original, here's the inverse. So if I wanted to prove that they are inverses, I'm going to take f of f inverse of x and make sure that it equals just x. So I'm going to take the inverse and plug it into the original. So I'm going to take this and plug it into the x there in the original. And it looks very complicated, but they usually end up being very simple. So instead of 2x to the third plus 5, it's going to be 2. And instead of x, I have third root x minus 5 over 2 to the third, and then plus 5. And I want to make sure that this equals x, right? And you don't have to do anything with this side, just simplify and make sure it equals x. So first things first, I noticed, PEMDAS, I'm going to do exponents first. So the third root and the third, those will just cancel each other out. So I get 2, and then x minus 5 over 2 plus 5. And then my 2's would cancel, so I get x minus 5 plus 5. And then my 5's would cancel, and eventually I would just get x, and that's basically your check, right? So you do want to show every step out. Don't just start crossing everything out, because you have to show me that you know the right order of operations. But that's pretty much it, right? Now again, I have to do it both ways, so now I'm going to do f inverse of f of x and make sure that that also equals x, right? And all I do for that one is plug in the original into the inverse. So instead of third root of x minus 5 over 2, it's going to be the third root of 2x to the third plus 5 minus 5 over 2. And the first thing I can simplify here are going to be the two 5's, right? I got plus 5 minus 5, so it's going to be the third root of 2x to the third over 2, right? Then my 2's would cancel. I'd have the third root of x to the third, and that would all just equal x, right? So I would get eventually x simplified. And what you notice is interesting, right, is that whatever we did here, the opposite order, right, it kind of went in opposite order. So like here, the last thing we did was cancel the 5's. Here, the first thing we did was cancel the 5's. Here, the second thing we did was the 2's, and second thing here was the 2's. The first thing we did here was the cubed root and the cubing, and that was the last thing we did over here, and that will always be the case. So that's just a proof to show you that two things are actually inverses. And then there's another way to prove it, which is even simpler. You just basically take a point and make sure if you plug in one, that the inverse coordinates you'd plug in for the other. There's some steps there, but we can just go through it, right? So if I said prove that these same two things are inverses, right? I could simply just pick a point, right? Take the original, and all I'm going to do is pick a point, right? So I'm going to plug in a very easy number to work with, like 0, right? If I plug in 0 into the original, right, I'm going to say, okay, 2 times 0 to the third plus 5. And that's going to be the same thing as 0 plus 5, right? I'm going to get 5. So the x value was 0, the y value was 5. And then I can prove that these are inverses. If I plug in the y value into the inverse, right, I can get the third root of 5. I'm going to plug in 5, minus 5 over 2, right? And that's going to give me this, I'm kind of working backwards here. It's going to give me the third root of 0 over 2, which is just the third root of 0, that's 0, right? So basically, I'm just showing that it undid each other. So this one has a coordinate point of 0, 5, and then the inverse should have a coordinate point of 5, comma 0. So I plug in 5 and I get 0. So that's called substitution. That will also prove that two things are inverses. All right, so here you go. You have 1 over 7x minus 2. Figure out if that's the inverse of 7x plus 2. So you can pause the video and do that. And you can figure that out by doing proofs of both methods. And then, once you're done with that, well, I kind of spoiled it, but you can do it out and see. You're going to see that they're not inverses of each other. And then what I want you to do is find the inverse. And then when we start class tomorrow, we'll go through that problem. Homework tonight is a worksheet. The sub will hand it out, but it's not due tomorrow. It's a 2-day worksheet since we're doing 2 days of inverses. So if you don't want to do it or you only want to do half of it, that's totally fine. See you guys tomorrow or next class.